Well, hello there again, friends. Today is 7/29/2022, and today is the Odin Project Vlog Day 137. Uh, I am on more testing JavaScript module here, uh, or section of the JavaScript module, and I am 54% complete with the section. And took today off via having my long on call last week, lots of calls, and having a long week this week, so I decided to take today off. So I'm recording this video now. I got through all the testing. Boy, there's a lot of information in here. Take your time with it for sure. There is a lot more than what meets the eye. The text here isn't too bad, but the documentation is quite a bit to read through. And then this video is, to me, was difficult. It covers what to test in your code base more is what they kind of want to focus you on. But I got lost because it's based on Ruby, and they say that doesn't matter at all, and the concepts ring true any language. And they say luckily Ruby's clear enough that you'll be able to follow along just fine. Me personally, I disagree with that statement. I did not follow along with Ruby at all. I did. It's a 32-minute video. I did get through it all, but I'm not gonna sit here and lie to you guys. I don't think I absorbed as much as I should/could have. But anyway, nevertheless, there's no coding today. Just a lot of discussion and reading about additional TDD and mocking and coupling code and stuff like that. More definitional stuff. So we're gonna go through the knowledge checks here. There's quite a few, so I'm gonna get right to it, and that'll round off the video for today. So what is tightly coupled code? So tightly coupled code basically means it's if you have functions that include references to functions in other part of your code, and the whole thing is filled with DOM methods or console.logs. So essentially, if you have callbacks inside of your function, it's called a tightly coupled function. Or if it's filled with DOM manipulation, like we've been doing, like create element or append child, or using console.log, which is in every one of my projects. So probably by definition, everything I've ever wrote has been tightly coupled. So tightly coupled code is hard to test. And they give an example here of tightly coupled code, which is what we're used to writing. It's hard to code because it's hard to test. Excuse me, if I was saying code, I meant test. It's hard to test because you got too many different things going on right now, and one test, it's hard to isolate it down to a unit because one unit may depend on something else. So you're getting all your units to pass, maybe a rather large challenge because it's dependent on other things that break. So you might get your first unit test to pass, but your second one might pass, but then your first one fails based on creating the test for the second one. So decoupling your code is the answer to that, and they go into more exact elaboration on how to do that. I won't go through that here. That's for your reading, but there's an example of basically breaking that one function out into two to making them loosely coupled. And that leads me into my next point of what are the two requirements for a function to be pure. So what I was just saying are technically pure functions. So the definition of a pure function is it always returns the same result if the same arguments are passed into it. It does not depend on any state or data change during a program's execution. It only depends on its input arguments. And secondly, the function does not produce an observable side effect such as network requests, input and output devices, data mutation, etc., etc. DOM manipulation. So basically, in our example that I was just talking about, was splitting the two functions out. Those could be defined as pure functions. So as long as they basically don't call out to anything, they don't manipulate any variables outside of that function, and basically everything's contained within. Think of it as kind of like the solid principle, the single scope, one function does one thing. So there's that. Okay. So that answers that. I think we're going right back to medium on this next one. What are the side effects and why is it important to identify them when testing a function? Yep. So what are side effects? So side effects is any interaction with the outside world from within the function. And this could be anything from changing a variable that exists outside the function to calling a method from within the function. As I just mentioned, those are side effects. Here's an example, but not limited to. So here's the HTTP request, mutating data, printing to screen or console, querying the DOM, using math.random. Not sure exactly why that's in there. I guess because it's using a method. And method is, I guess, a side effect, I assume. Getting the current time. Basically, if it's got to go to a method or go to anything outside of itself, as in that function, it has a side effect and it's not pure. So it says, note if a pure function calls a pure function that isn't a side effect and the calling function is still pure. So basically, if you have a pure function that calls a pure function, that's not a side effect and it's still a pure function. Did I answer all that? Important to identify them when testing a function. So it's important to identify them when testing a function. We kind of answered that already with the previous one of why we have a pure, what is a pure, and why we want to get rid of tightly coupled code. Because it's hard to test. I just went over that a minute ago in the example of you have two units. You're testing unit, unit function, unit A, unit B. But then when you create B and solve for B, A fails because A is dependent upon B. That's because of tightly coupled with the side effects. So it's important to either get rid of the side effect or mock the side effect, which we will talk about here in a moment. You can mock it, mock the side effect, whatever that is, whatever that may be, and get the unit test to pass. There are limitations to that as well. What are two solutions to the tightly coupled code problem? The two solutions to the tightly coupled code problem. The first one and the best option is simply remove these dependencies from your code, as we did above, but that's simply not always possible. So if you can't remove the dependency from your code, the second option I just mentioned is mocking, which is writing fake versions of a function that always behave exactly how you want. For example, if you're testing a function that gets info from a DOM and you really don't want to have it set up a web page, you don't really have to set up a web page and dynamically insert something into the input just to run your test. With a mock function, you could create a fake version of the input grabbing function that always returns a specific value that uses that in your test. So that was actually showcased in Fun Function. The creator of that YouTube channel, he went through it. If you watch the rest of the series, like I did a couple videos ago and recommended to you, he goes through actually mocking and how he does his mocking. It probably isn't the only way. Again, may not be the right way, but he broke it out in an easy to understand way to do that. He was basically doing mocks for async test. Okay. What is mocking? We basically just went over that, so I don't know why I clicked on that. Oh, come on. Now my browser's acting up. What in the world? Am I still recording? Yes. So, looks like I have lost my browser. Just fun. Hang tight, guys. I think I have a bug in an update I received a while back. What is that? History. Reload previous session. Okay. Alright. So we went through mocking. When would you use a mock function? When would you use a mock function? Oh, we already went over that. That's the example here. If you're using a testing function and get information from a DOM, you really don't want to create a whole site and set it all up, a webpack and everything, just to create a test. So you could create a mock that creates a fake version of the input grabbing function that always returns the specific value. So if you know that you're getting a certain value from your web page or from the user, you just input that as your test. That's your mock. You don't need to create the if you know that that's always the same, and that variable or that information supplied is always the same, then just create a mock for it. Would be the fastest way and easiest way. Only if the information is always static and doesn't change. How should you test incoming query message? So these next four, I'm not going to click on them because they go to that YouTube video that's right here that talks about what to test in your code base with Ruby, using Ruby. So I kind of went through the video already and I took notes. So I'm just going to read from my notepad. I know it's not the funnest thing to watch, but it's better than clicking on that YouTube video because that doesn't make any sense either. So the first question is, how should you test incoming query messages? So essentially, I'm kind of abbreviating here, but you want to test the interface, not the implementation. And secondly, you want to make assertions about the incoming message. So you don't want to. So that's how you should test your incoming query messages. Don't test the implementation, test the interface, and make the assertions about the incoming message. So the assertion, if you remember, is the .2b or .2 equal, .2 strict, that sort of thing. So make the assertion about the incoming message. Second question is, why should you not test implementation? And that is because implementation is based on the interface. You are testing the wrong thing. You always want to test the interface instead. Implementation can change, and so the way that it's implemented, the code that's existing in there should not be tested because that's subject to change. It doesn't make sense basically to test that because if it doesn't really matter if it passes or fails, because if you test the interface it's sitting on, which is contains the incoming message and all that, and the outgoing message, whatever your API is doing, that's what you really need to test because that's what is being spit out and ingested. So it doesn't really make sense to test an implementation. Should you test private methods? The rule here, she kind of mentioned the rule is no. Don't make assertions about their result. Don't expect to send them. But she said there is a caveat. The caveat is to test them if it saves you money during the development stage. So if you're working for a company and you're in the development stage and there is a need to test the private methods because it might save you from a massive bug that might cost your company $1 million in losses, then it's worth it to go ahead and test it. But that's the only caveat. But the rule is no, because you don't want to make assertions about the result, and you don't expect to send them. You don't expect the receiver to test them either. So hope that made sense. And the last one, why should you not test messages with no side effects? This is because the sender should not test it. It's a waste of time, no value added. There's no side effects, there's nothing really to test. Ignore it, move on. We kind of mentioned that above here when I was talking about side effects. If there's no side effects, it's technically a pure function. So in this instance, with testing messages with no side effects, there's really no point in it. It's kind of the same answer as with testing the testing private methods. It's really the same thing. There's really no point to it. There's no real value added because there's no side effects. It's ideally a pure message inside of a pure function that's doing one thing, taking a parameter or two and doing something with it and spitting that return result out. It's not doing callbacks. There's no other side effects. It's not going to the DOM for anything that might be a variable of information. It's always the same. So you just basically ignore it and move on. And that is it. So don't want to drag this out too long. Hope this wasn't boring. I know sometimes these are dry to watch when there's no code and there's a lot of reading, but this is a lot to understand. So take your time with it. It took me several days to get through this, going off and on, and an hour or so each of study time, so you don't burn yourself out, and that's kind of how I approach it. So anyway, hope you enjoyed the journey today and come along for the ride. With all that said, please like, share, and subscribe for more content, and let me know in the comments section what you guys are thinking about and how you guys are handling ingesting TDD and testing practices and all that. So with all that said, again, until next time, see ya.